Okay, so here we go. Last uh, review set here for the final or the practice final, the last four problems, 25 through 29. These have to do with solving rational equation or solving radical equations. So what's our strategy? When we're solving radical equations, quick summary, we want to isolate the radical that we're trying to get rid of or rewrite in without a radical. Isolate that radical and then take both sides to whatever power we need to undo the radical, so to speak. So this is a square root, so we'd have to square both sides. This is a pretty easy one because the radical is already isolated, right? So all I'm going to do here is just square both sides. If I square the left side, it undoes the radical, and so I end up with just plain old x plus 24. On the right side, I end up with 12 squared, which is 144. So there's only one step left here, and that is to subtract 24 from both sides, and I get x equals positive 120. Okay, one thing we got to keep track of here, though. When we take both sides of an equation to an even power, we introduce the possibility of extraneous solutions or invalid solutions. And so we always need to plug the value of x that we get back into the original equation to see if it works. So if we try out x equals 120, what happens to our original equation? We get the square root of 120 plus 24 is 144 equals 12, which is true. So 120 is a valid answer. Okay. Moving on, another one here. This one looks a little harder, but it really isn't because in this problem here, I've actually got square roots on both sides of an equation, and so therefore they're both isolated. And so if I square both sides of this equation, it's going to cancel both of those square roots. And so we end up with negative 9, that's bad color. We end up with negative 9, that's a little better, x minus 8 equals negative 2x plus 2. Well, we'll just solve that equation for x. So let's go ahead and move the x's to the side where they're positive. So I'll add 9x to both sides, push the numbers the other way, subtract 2 from both sides, and we end up with negative 10 equals 7x. So if I divide each side through by 7, x equals negative 10 sevenths. Okay, well, I'd have to once again check that, see if it works. If I plug that into the original equation, I get the square root of negative 9 times negative 10 sevenths minus 8 on the left equals, on the right, the square root of negative 2 times negative 10 sevenths plus 2. So what do we get under the radical on the left? Negative 9 times negative 10 is 90. So I get the square root of 90 sevenths minus 8 over 1. If I get a common denominator by multiplying top and bottom by 7, that gives me the square root of 90 minus 56 over 7, which is the square root of, what is that, 90 minus 56, so 34 sevenths. I'm not going to simplify that any further. I just need to see if I get the same thing on the other side. Well, if I multiply, let's see, if I multiply negative 2 times negative 10 sevenths, that's going to give me a 20 sevenths plus 2 over 1. Well, let's just multiply the 2 over 1 times 7 over 7, and that's going to give me the square root of 20 sevenths plus 14 sevenths, which we see is equal to the square root of 34 sevenths. And so these two are equal. And And so my valid answer is -10/7. Okay, this one's a little tougher. This time we do have a radical that's isolated, and so just like before, we're going to square both sides, which means I have to square everything on both sides. Square the quantity x plus 1 on the right and the square root on the left. Squaring the square root undoes the radical. So on the left side we get -6x plus 1. On the right, x plus 1 quantity squared works out to be x squared plus 2x plus 1. And so now I'm just going to put this into standard form and solve. I'll add 6x and subtract 1 from both sides, and that gives us, on the right, we get x squared plus 8x plus 0, and that's all equal to 0. So then we could just factor out an x, so this is a really easy one, and then my solutions are going to be either x equals 0 or x equals -8. Let's check both of those and see if they work. So if I check x equals 0, I get on the left the square root of -6 times 0 is 0 plus 1. So the square root of 1 equals 0 plus 1, which is 1. That's true. So 0 is a valid answer. What about -8? Okay, we can already see we're going to have a problem. When I plug -8 on the right side of the equation, or plug it in on the right side of the equation, I get a negative result. And we know that, let's get rid of this stuff. We know that the output of a square root, at least a square root of real numbers, cannot be negative. And so we already know that's not going to work. If we just, what if we didn't see that though? If we plug these in, we can still show pretty easily that we're going to get different stuff on the left and the right. On the left, we end up with the square root of -6 times -8 is positive 48 plus 1 is the square root of 49. Is that equal to -8 plus 1, which is -7? No, it's not. And so -8 is not a valid solution. It would be wrong to include that solution. So our only valid solution is x equals 0. Okay, last problem. This is the hardest of the three. In this case, we've got radicals on both sides, but the problem here is that I can't simultaneously isolate both radicals. So I'm going to have to get rid of the radicals or undo the radicals one at a time. If I square both sides to begin with, it undoes the radical on the right, which is useful. But what do I get on the left? Well, if I just use the pattern a plus b squared equals a squared plus 2ab plus b squared, where the square root of x plus 2x is a and 1x is b, when I square that out, I get a squared, which would be the square root of x plus 2 squared. So just plain old x plus 2 plus 2 times a times b is 2 times the square root of x plus 2 plus b squared, well, 1 squared is 1, equals, on the right side, I just get an x plus 7. Okay, that's pretty useful because I can combine, let's go ahead and combine like terms. So I get x plus 2 times the square root of x plus 2, and then 2 plus 1 is 3. And over here I get x plus 7. If I subtract x from both sides, the x's cancel. And so now all I've got to do, I've got one more radical to deal with. I have to isolate that radical and square both sides again. So let's subtract 3 from both sides. That gives me 2 times the square root of x plus 2 equals 4. Divide by 2. And I get the square root of x plus 2 equals 2. If I square both sides, I get x plus 2 equals 4. Subtracting 2, I get x equals 2. Single solution. So let's go back and check it in the original and see if it works. So if I plug that into the original, what was it again, 2? If I plug in 2 on the left side, I'd get the square root of 2 plus 2 is the square root of 4 plus 1 equals the square root of 2 plus 7, which is the square root of 9. Well, that gives us 2 plus 1 equals 3, which checks. And so we do get the valid solution, x equals 2. All right, that's it.